All right, good morning, second period. I hope you had a great weekend. Couple quick housekeeping items. First, I'm at a doctor's appointment and I might actually walk into class later in the period, but I wasn't sure if I was going to make it back in time, so that's why you're watching this video. Quizzes will be returned to you in just a little bit. The answer key for our quiz is posted below on one of the links. So when you get your quiz back, if you'd like to review your answers and see what you got wrong, you can do that. Test is on Thursday of this week. Wednesday, we will be having a help session in the morning and also in the evening. I think that's it. All right, let's get started. So last week, you and I were operating 100% in the land of solutions. That's right. Everything that you see here with these games that we were playing, all these things, look at all these things, all these things. These are all possible potential solutions to problems. Now, the funny thing is, we didn't see the problems. We only saw the result of the problems. And so you might remember we were talking about interval notation, inequality notation, number lines, and all of the things here are solutions to problems that we did not see. Well, now you'll notice you have a sheet, and here are the original problems. These are the OGs. These are the things that made those different solutions. So what we're going to do is we're just going to review some of these basic steps for solving inequalities, and then I will get out of your way and I'll let you keep working. So first, on example A, we're going to solve this inequality just like we would an equation. So we're going to add 4 to both sides, and that'll give us x over 5 less than or equal to 34. And then we're going to go ahead and multiply both sides by 5. And so that will tell us that the mystery number has to be less than or equal to 170. You'll notice though, when you go down to the bottom to write your final answer, it might ask you for a different representation. In this case, we want to show all of the numbers less than or equal to 170, but we want to do it using an interval notation. So that means that we could have any value from negative infinity all the way up to 170, inclusive on 170, and that will be our final solution. All right, check out example B. So we have another simple inequality here because we only have a variable in one location. It's not an or statement or an and statement. So I'm going to go ahead and use the distributive property here to get us started. So negative 14 plus 28x plus 2x. Now I can go ahead and combine my like terms. So negative 194 less than negative 14 plus 30x. I can go ahead and add 14 to both sides. And that will be negative 180 is greater than 30x. Divide both sides by 30. And x is going to be less than negative 60. Negative 6. And since we're going to be writing this in an inequality notation, technically we're already done, but keep in mind, you could write this solution like this if you wanted to, where you just simply flip the inequality in the opposite direction so that you can write your variable first. I'm going to do that because that feels just a little bit more appropriate. So x is less than or equal to 6. So again, both of these are actually review from Math 7 because we are solving simple inequalities. All right, let's kick it up and go to example C. You'll notice that this is a compound and inequality, and it's actually pretty cool. The first thing we're going to do, like I'm sure you're imagining, is we're going to subtract 2 from all sides. That's right, not both sides, all sides. So we're going to subtract 2 here, subtract 2 here, subtract 2 here, and that will give us negative 54 is less than 6k, which is less than or equal to negative 24. Then we're going to divide all sides by 6 so that k will be isolated. So divide by 6 everywhere. So that'll be negative 9 less than k less than or equal to negative 4. And now you'll notice that we're given this number line here. And the number line is really just to use as a sketch. It should not be a hyper-realistic number line. So what I'm going to do is I'm just going to put like 0 right here. And then negative 4. And I don't know, negative 9 can be here. This is just a sketch. It's going to be an open circle on negative 9, because it's not inclusive, and a closed circle on negative 4, and then we're going to shade in between them. Beautiful. So again, this is a compound and inequality. And you'll notice that we're still isolating the variable, but we have to move everything, our inverse operations, we have to use those inverse operations to all sides. All right, last one. Here is our compound OR. And because this is an OR statement, it means that we could have n over here or over here. So what we're going to do is we're actually going to solve both of them individually. So I'm just going to solve the one on the left first by subtracting 10 from both sides. So that means that n, oh, that was a terrible n is greater than negative 4. Or, now we got to solve this other side. So we'll start by subtracting 6 as our first inverse operation. So it'll be negative 10n greater than or equal to 90. Divide both sides by a negative 10. And you might recall, when you multiply or divide by a negative value on this last step, you do have to switch the inequality to make sure that it stays true. So we are looking for all the numbers less than or equal to negative 9, or all the numbers greater than negative 4. So to put this in interval notation, we would want to go from negative infinity all the way up to negative 9 inclusive, or 4 to infinity not inclusive. And so those are examples of not only solving inequalities that are from Math 7, but also it shows you how you solve compound OR and compound AND inequalities. All right, I'm going to get out of your way. I'm going to let you try the first 4 here. The answer key is posted below, and this is your homework tonight. All 12 are your homework tonight. Okay, see you soon.